Hello, hello, hello. My name is Chef, and I'm here to do a coding problem. And welcome to my channel. It's been a while since I've done one, and I feel like I just want to get back into them again. So I just picked a random one called first. Find the index of the first occurrence in a string. This is a classical problem. And by the way, if you like my videos, like and subscribe. Helps motivate me to do more. Anyway, this is a classical problem, I believe. I think a long time ago I've seen this. And it's problem 28, so it's probably one of the very early ones. So given two strings, needle and haystack, return the index of the first occurrence of needle in haystack, or -1 if needle is not part of haystack. And so here's the two examples. You have haystack equals sad but sad, and needle equals sad. So basically, you find that needle is found in the haystack as the first occurrence in the haystack of the first three letters. So we output 0. Sad occurs at index 0 and 6, okay? And the first occurrence is at index 0. Second example is that haystack equals leet code, needle equals leet 2. So leet 2 is not contained in leet code at all, right? So leet 2 did not occur in leet code, so we return -1. Okay, because you're missing the CO, right? Instead, you just have the TO. Okay, so this problem actually is. We'll start with our test cases. This problem is, I would say, a little bit tricky. Okay, it has a 46 or 41% acceptance rate, even though it's considered as an easy problem. So we'll start first with the trivial cases, and then I'll get into why this is a tricky problem. Stack is length at 0. So this is the first trivial case, right? If the needle is greater than the haystack, then the needle is clearly not in the haystack, right? If the needle length is greater, okay? Second case is another trivial case. If the needle dot length is equal to haystack dot length, if the needle, this can totally happen. If they're equal, then what we need to do is, if their lengths are equal, we have to check if their contents are exactly equal. And if their contents are exactly equal, needle, we can just do a string comparison, haystack. And we'll say that if they're equal in content and length, then just return 0 because that's the first position. Otherwise, the needle cannot possibly be contained in the haystack if they're of equal length, but they differ if any of their equality differs, right, at all, because the needle is the haystack. Okay, so what do we do here? How do we tackle the main part of the problem, the non-trivial cases? So the first thing you imagine is that you want to iterate through this haystack and look for this needle. Okay, so we can do a character comparison. We can do, let's say haystack is, we'll go one by one. Haystack is, haystack equals sad but sad, and needle equals sad. Okay, cool. And so that all we have to do is S, I'll say S equals S, A equals A, D equals D, and voila, we're done. Okay. Now, it looks simple, right? But it's not that simple. So let's try this case, sad but sad. So what happens here? We have S is equal to S, A equals to A, but D is not equal to B. So what we have to do is continue iterating. We move B, U, T, S, and once we get to S, we can start iterating again. S is equal to S, S is equal to S, A is equal to A, D is equal to D. And I bet you're saying to yourself now, awesome, we got this, okay? But this is not that easy. There's a further trick in here. Let's say haystack is equal to a word like Mississippi. Okay. You'll see what I'm saying in a second. And then the needle is equal to ISIP. Okay. So let's go through this. We have m is equal to, we have m is equal to nothing, right? So we ignore m. We have I is equal to I equals I, s equals s equals s, I equals I, and p is not equal to s, not equals s. Okay, so what do we have here, right? We're like, okay, logically, then we just start again at this character here, right? S, and then we continue, this seventh character. But that's not good enough. No, we can't just do that. Why can't we just do that? Because we already, in our internal iteration, when we're doing a comparison, we hit another ISIS here. The first three characters, ISS, of our needle were found again within the part of the haystack we were originally searching in. So we can't simply go to the end of the haystack. We have to go back within the part of the haystack we searched already, because we did find a part of the needle in that haystack. So this is where it gets tricky, and the way that I'm going to do this is, I think, possibly one of the more straightforward ways. There's some fancy ways to do this, I'm sure, but so what I'm going to do is I'm going to define 3 indices, actually 4 indices. I equals 0, j equals 0, I equals 0 will be in a loop, and k equals 0, and l equals 0. Okay, now you'll see why I'm doing this. Okay, so the first thing is we write our main iteration, right? So I is less than haystack dot length, I plus plus. What does that mean? Okay, so this is where we're just iterating top level through our haystack. Okay, and then you might be asking yourself, why do I have all these other indices here? I mean, I'm just looking. Well, just for the case that I just mentioned, right? So the first thing we're going to do is car h, the haystack character, haystack car at I. Okay, and then car n, the needle character, is equal to needle dot car at k. Now I have this second character extracted, and I plan to use this, and I plan to set this against k, because k is the needle's internal index as we search through the needle itself while we're also looking through the haystack. You'll see why I have this set up in a moment. So let's check if in the iteration the haystack character equals the needle character, right? Then we can start doing like equalities in here, okay? We start checking indices. So first thing we do is, and this should be, I believe, -1. So first thing we do is j equals -1, j equals I. This is what I'm doing here. And now what did I do here? This is a trick, because I want, if j is equal to -1, this j iterator, I want this j iterator to start doing stuff at the first catch of the internal iteration block where h is equal to n. And then that's what I'm doing here. I'm setting it equal to something. And that will, this is kind of like a flag, this -1 here. Okay, you'll see, again, if you don't understand, I'll explain it, I'll try to. Now, if h is equal to needle that car at 0, this is now how I resolve the partial haystack needle problem that I mentioned. Okay, now you can see I have this L index here as well. So L is going to be the last place internally. L is going to be the last place internally where I move my character back to indicate a partial need to return to the haystack, because it's the next place I found the IPPI. Okay, again, a tricky kind of thing here a little bit, but you'll see. And why am I setting it to car at needle 0? Because this is we want to look for instances when we find the first a character of the needle in the haystack. Okay, that's where we move our overall index back to. Okay, so I'm going to say L here is equal to j, the last place we found this start of the needle character. Then we're going to move our internal loop forward. Okay, our internal needle not internal loop. We only have one. Well, we have more than one loop, but for now it's actually a little bit hidden. But I'm talking about the needle iterator. We'll move the needle iterator forward, and if k, the needle iterator, is equal to needle length, then what we do is we return j. Because at this point, this is where we've found the needle in the haystack, and there's no need to continue any more iterations external to this loop. Okay, so, and that happens if so far we haven't collapsed this loop and k is equal to needle.length. That means we've gotten to the end of the needle iteration because we're at the length of the needle. Okay, with k. Now, here is possibly the trickiest part of this. If we don't find the two characters to be equivalent, there's several things we need to do, and a case we need to take care of. So we reset the needle iterator back to 0 because we're like, okay, well, we'll start back at, in sad but true, we'll start back at s, sad. So that's where k turns into, right? If j equals -1, okay. Or j, we said, no, sorry, not if j is, we reset j back to -1 because now we're resetting the flag, the initial flag condition, to tell the j iterator to move forward. Okay, so, or tell the internal needle iterator to move forward. This is again a flag. It's a cute way of doing a flag, in my opinion, but you know, if you do it enough, because I don't need to maintain a separate boolean or anything to maintain this flag. So now, if L is greater than -1, here's where the ultimate trick comes into play. Okay, if L is greater than -1, that means we found a last iteration index, right, through the use of another flag that corresponds to the position of the needle's character, first character, which, remember, we have it isolated in this condition here. Then we say I is equal to L, because now we're saying we are resetting the external index. This is the trickiest part. We need to reset the external index, right? Because that is going to be the thing that controls the overall iteration. And most times you see loops and things like that, you're not touching this, right? In fact, if you're Kotlin people, you can't even touch this. So this is kind of like a Java-only trick. But I'm resetting the external iterator there because I need to go back. And L is equal to -1 because now we reset the flag. We don't need to keep track anymore. We've already set I equal to L. So now if L had a value, meaning we found an actual reason to set L because we found the place where the H is equal to the needle's first character, right? H, the haystack's character, equals to the needle's first character within a haystack, then we say that L, the last character, is equal to I. Okay? Because now this is the next place that we want to look when our iteration moves forward. Okay, you'll get it if you think about it a bit, but I'm going to let you know that this is what I call it resetting the internal character. Okay. And now, are we done yet? No, we still have one little thing to do. This is so far this should capture the logic of the loop. We have one more thing to do. Return -1 if we exit the overall loop. Remember, that's the condition of, like, there's nothing to find here. Okay. Now let's run this. Test case 1 accepted. Test case 2 accepted. Let's try submitting it. And there we go. We're doing better than 76.09% of users with Java, and we're at runtime 1 millisecond, 36.38 users with Java. There is, we're like kind of here. There's a faster solution. We'll look at that faster solution. Well, you can look at it, but for now I'm happy with this, and this was kind of tricky because I think this handled these internal haystack cases. So, yep. If you like my videos, like, subscribe, and I'll see you around next time. Peace.